We'll do a quick recap. Okay, so now I'm recording. So where we left off last time was about how exceptions are handled, right? And remember, there are two starting rules. So let's bring that into let's bring it into Paint. Paint is better. So number one, all checked exceptions must be handled either locally, right, in the method where they can occur, or else in one of the methods that calls the exception generating method. Okay, so for example, a method M1 could generate a checked exception, right? Could be handled either in M1 itself or by any method or by methods that call M1 or methods that call those methods, or so on, and so on. Okay, so somewhere in the stack, somewhere in the sequence of method calls leading to M1, exception handling must be present. Otherwise, the code will not compile and you can't run it. So there's that. If it's a checked exception, there's that. Number two, all runtime exceptions don't have to be handled. However, if they're not handled, a runtime exception will potentially crash the program. All right. Now, there's a whole thing in Java about which exceptions are runtime and which exceptions are checked and why it's a big hassle and why it isn't. And I'll give you an example. So, for example, not an example with these. On the topic of why some exceptions are checked and others aren't, well, one thing, exceptions that can be prevented entirely by good program design generally don't need to be checked exceptions, right? For example, array index out of bounds exception, right? Or the exception for getting a negative array index. Those are things that in a well-designed program simply should not happen. So we don't need to force programmers to handle them. And really, it would be a huge pain to have to provide exception handling for every access of an array element, right? That would be a big pain in the ass. A lot of programs use arrays, and if you had to put in exception handling every time you access, because it could be an array index out of bounds, or it could be a negative array index exception, we don't want to do that. It's a hassle. It would suck. Okay, it would suck more than programming already does. Haha. Just kidding. We all love programming. Okay, that was a test. Anyway. Okay, other thing, serious problems that are unpredictable are often checked, right? For example, file input-output operations could fail, right, in a variety of ways, but certainly due to hardware defects, right? Basically, your hard drive shits itself, and you have some program that tries to access it. Well, there's going to be some kind of exception there. Guess what? Your whole program just crashed, right? So, and that's not a good programming design issue. That's just the reality that components sometimes fail. So, anyway, that's some of the logic behind it. But any exception can crash your program and ruin your day for sure. All right. Anyway, so the way to do this, right, here we have our two basic methods, our two basic approaches of how to handle exceptions. This is for a checked exception. So if there's a method that can generate a checked exception, one possibility, of course, is that it gets handled locally, right? So this method over here on the right, do work, it throws an exception. It could handle it locally itself, but it doesn't. So that means one option is caller A that calls that method do work can embed that method in a try catch block and thus handle the exception that way. Or it could kick it back, right? So whatever method here calls caller B, well, guess what? Caller B can throw an exception that's generated by new work because caller B itself calls new work. It doesn't handle that exception locally, but whatever method called caller B would have to handle it, or the method that called that method that called caller B, or so on. Okay. Now for runtime exceptions, you don't have to do that, right? Runtime exceptions, it's never obligatory to handle the exceptions. However, in many cases, it can be a good idea. So, for example, here we have caller A calls do work. Well, it's embedded do work in a try catch block. This one, caller B, is going to throw that runtime exception, right? It's going to just mention it in the header that, hey, here's a friendly warning. I'm calling a method that is known to occasionally throw a runtime exception. If you're calling me, you might want to handle this. But again, because it's a runtime exception, there's no obligation to do it. Just like caller C down here, it can call do work. It doesn't have to handle that runtime exception. Yeah, I mean, it's probably a good idea to, but it doesn't have to. Okay. Now, so that's just wrapping up what we covered last time at the end. Another thing, we can have our standard exception classes, but of course we can make custom exception classes. And typically the reason why you do that is to provide some sort of diagnostic information, right? You can create an exception class that anytime something goes wrong, you can pack in some useful information. For example, suppose you have some method that, well, one of the things I was doing when I was wrapping up my dissertation about 10 years ago, I was doing these very large network simulations. So it was basically the idea there were a bunch of cars randoming around, sometimes pedestrians, but mostly cars randoming around with mobile devices transmitting messages to each other. And sometimes, you know, the program would crash. So in many cases, what I did was just to do some screen dump of what happened, right? So I would say, I would just print out some text of the particular variables that I was looking at. But another way I could have done it is to create my own custom exception class for that project and say, hey, anytime, you know, this, I put in some new code, I embed it in a try catch block, and anytime something goes wrong, I throw that kind of exception, right? And I embed all the variables that I want to be shown, I put them in the message. And that's the nice thing about that, it's easier to clean up afterward. So if I want it to be, you know, more efficient, instead of saying I have some, you know, void method, whatever, right? And many lines of code, several lines of diagnostics, right? Periodically displayed. Instead, right, I could be more efficient to just say many lines of code, put this in a try block, okay? And if something goes wrong, catch, you know, exception E, whatever my exception is, and display relevant variable state. And in many cases too, this is a lot easier than using the debugger. Stepping through things, like when you're doing stuff at that big, I was literally, you know, the operations I was doing, they would go through this stuff like millions and millions of times. And you're not gonna sit there and, you know, just press the go forward, the step by step through the debugger with that. But this is a way that you can, you know, display contents of things. In fact, if you wanted to, you could simply say, if you wanted to just display this stuff, you could just force it, right? You could simply say at the end, if true, throw new exception, right? With some string message inside it. You could do that. If you just wanted to force a diagnostic screen dump at the end, you could do that. So anyway, exception handling, sure, it's useful for its intended purpose, but you can also use it to do diagnostics during a program as well. All right. So anyway, what programmer defined exceptions, we had some of those in the work we did the other day, right? So I had a short password exception, and this one, you know, we had them there, and we didn't really do anything meaningful with them. But one thing I could do is I could have a string, you know, text, right? So I could do something like void set message. Okay, I could give it a private string message if I wanted to. So here I could do, okay, and say this dot message equals, oh shit, didn't mean to do that. I meant to do that. This dot message equals message, and I do the same thing in here in just a second, and then string get message. Do I have to? Okay, so if I wanted to give each of these their own message thing, and I could say, you know, if I wanted to do a custom message, for example, I could do something like, I could set it, for example, now I've forgotten what I'm doing here. I'm getting the thing, the main update password, temp password. Okay, it has temp password. So I would do e dot set message temp password, f dot send password. Okay, so I could set that to be the message, and I could include that, for example, when I call this method, and I could do something like system.out.println, and I could recover it from it. So I could do e dot get message is not an acceptable password. Okay, and the same thing I could do here, right? Again. So if I wanted to, I could display that using some custom methods here to manage the message contents. And if I wanted to, again, I could parse that and see gloob is not an acceptable password. And I would have that method here. And if I wanted to, I could come up with another thing. For example, I could say, you know, gloob is only 5 letters. It needs to be at least 8. Or if I have a variety of other message, you know, things, I could come up with more customized error messages for why the password is inadequate. Okay. So there's that. Now the example they give here, there's a running example in the slides where it asks for someone's age, And if it's greater than like 130, that says, well, that can't possibly be true. We're going to treat that as an exception. So this one, age input exception, they create a custom subclass of exception that has these three bits of information, right? So for the particular point in the application, it says has lower and upper bounds of the acceptable age. So your age could be 0, right? It could be less than 1 year old in principle. And the upper age would be 130, because as far as we know, nobody's lived longer than that. And then the invalid value that was entered. Same kind of stuff. So anyway, typically the reason why you would make these kind of custom exception classes is in order to make custom messages and pack in whatever different kinds of data you want, because the other stuff is basically all going to be the same. Now, the last new thing is assertions. Let's talk about what assertions are first. An assertion is basically a check that the program is working correctly. So simply, if the program is working correctly, you run the assertion statement and nothing happens, because the assertion is true, right? So the assertion will evaluate to true if the program is running correctly. Otherwise, the assertion will be evaluated as false and will throw an assertion error. Okay, so basically there's a Boolean associated with the assertion. So let's say, for example, you've deposited some cash into your bank account. What should naturally happen? Well, obviously, that should make your balance go up, right? But it is possible due to weird Java math or hardware failures, for example, that your balance might actually go down. Okay, that is a serious problem, but you know, it's at least theoretically possible. So the bank might wish to assert after a deposit that the new balance is greater than the old balance, right? You have more money in there than should be. And if that's not the case, well, you know something went horribly, horribly, horribly wrong, okay? Likewise, after a withdrawal, the bank might wish to assert that the new balance is less than the old balance, okay? Because again, if not, something's gone seriously wrong. You withdrew some money and your bank account went up. Well, that's a bank account I want to regularly withdraw money from. Okay. Although I suppose it doesn't really matter. It's just an infinite amount anyway at that point. All right, so that's assertions. Well, let's take a little bit more look in there. So the basic syntax, you have assert, and then there's some Boolean expression that, you know, it's a Boolean, so it's true or false. If this Boolean expression is true, that means the program is working correctly. So that's how you have to write the expression. For example, you could assert new balance greater than old balance following a deposit, or assert old balance greater than new balance after a withdrawal. Anyway, if the expression results in false, it throws an assertion error, okay? Because something went horribly wrong. So here's our example, exactly the stuff I talked about. We have a deposit, throw in some amount in your bank. You have save your old balance as old balance, right? And then add the amount to your actual balance, and then verify after the deposit that your new balance, right, your updated balance value is in fact greater than your old balance. Likewise, for withdrawing a certain amount, at the end you verify that your new balance, excuse me, is less than your old balance, as it should be. Okay. You can also do it this way, right? If you want to send a message along, that would be the expression, right? So that's the detailed message of whatever error gets thrown. So you can say assert old balance greater than new balance after a withdrawal, and the expression could say serious hardware, serious system failure, money, cash withdrawn, account balance went up. Oh no, what do we do? So you could have that. And here's that, right? So again, deposit, the balance increased by amount, and then you assert that the new balance is greater than the old balance. And if it didn't, you send along this message, right? Serious error, balance did not increase after deposit. Okay, now how do you get assertions? Well, first of all, you can run one program with them enabled in the run configuration window. So in your virtual machine arguments, enter the argument -EA. Okay, so I could do that. Do that here. Run configurations, and over here on arguments, in my VM arguments virtual machine, right? EA, which stands for enable assertions. Click apply. Hey, what the heck? Let's run it. Let's see what happens. Okay, but I'm not doing anything with them yet, so I guess it doesn't matter. I'm just going to stop this. Okay. So let's do an assertion here. Okay, so if this is correct, right, I could do something like, for example, assert f.password .length is greater than or equal to 8, and f.password .length is less than or equal to 12. Okay, this Boolean expression should be true if the program is working correctly, right? So I can run this with assertions enabled, nothing will happen, right? I'll enter in a correct password. So let's do 1, 2, 3, 4, 5, 6, 7, 8, 9. Password's updated, great. Now, if I want to do this the other way, right, if I wanted to make something go horribly wrong, okay, I could simply assert not that. And then this will definitely throw an assertion error. Okay, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ah, I got my assertion error. That's a problem. And you can handle assertion errors same way as any other exception, right? So you can say try and then catch assertion error AE. Okay, and that's what you use to catch the assertion problem. And I could send along something like system.out.println serious failure, password update feature not working. Okay, and then exiting application, and then system.exit 0. Actually, let's put a code for that. That would be our assertion error code. Arbitrarily chosen as assertion error code. Okay, so I can run this. Okay, and there it goes. It catches it the same way, right? Serious failure, password update feature not working, exiting application. Great. Okay, now, so that's one, right? If you want to run programs with assertions, that's how you would do it. The other possibility, if you want to do it as a default option, go to Windows Preferences, Java, Install JREs, select your particular JRE, and in the Edit menu, add EA to default virtual machine arguments. Okay, so let's go. Window, preferences, Java. Okay, down below that, right, we have install JREs, right? So I can pick one of them, right? I select this one, I do edit, and digging down in there, default virtual machine arguments, that means for everything that's running with this particular JRE, I enable assertions, right? I finish that, boom, I apply. Now, even if I go here and in this app, you know, in my run configurations, even if I get rid of that, it should still work. Let's see. There it goes. Even though I disabled assertions, because I've set a global thing where everything using that JRE is going to have assertions. Well, there they are. They're still present. Okay, so that's it, right? We covered our stuff. We're done. How's everything? You want to do some coding bat? I don't know. I'll do a little coding bat. Or it's Friday. I don't know. Maybe you guys all have hot dates with Susie and Chad. Susie or Chad. Maybe application. Yeah, okay. I'll talk about that. I'll talk about the application assignment since you're all here.
Hey, Professor.
Yeah.
I just had a quick question in regards to the application assignment.
Okay.
Are we able to make any adjustments to the e-tracker and the employee code?
Yeah. Those are a starting point. You'll need to make some adjustments. I don't think
okay.
To make adjustments to employee, although maybe you will. I haven't looked at this since I wrote it, but I mean, you'll definitely need to modify e-tracker.
Yeah, because I was having some issues with the private. So if I switch it to public, then
no, you still got to keep those. You'll have to make a new method, right? So
okay,
I'll pop up the code on them, and I'll show you what was different. Right? Remember,
you have to keep like the fundamentals the same.
Basic structure will be the same. Yeah, you just got
okay.
Stuff. So, right, this was the announcement I put out. Was it last week? Again, should have been a method in place for updating the employee.id field, right? Since employee.id is private, yeah, you want to put in a method to do that. The other thing, the create command was supposed to actually create the new employee in the array E. Okay, so I did that. That's present in the two files you have now. So, I mean, that made sense, right? You call create, it should actually create the new employee object in your existing array. Otherwise, what's the point, right? The way the assignment was written, yeah, it makes this new employee object, but it doesn't do anything with it. And, you know, it's going to be immediately forgotten as soon as you exit the method. So that was kind of silly. The way I've implemented these things, because I wanted to be minimally disruptive to the way everything worked, right? If you look up e-tracker here, boom. Okay, where's my create method? Here it is. What I have, every e-tracker object has a private employee EMP. And EMP is your temporary employee, right? It's your scratch paper that, for example, if you create an employee, EMP is going to be that employee. Then it's persistent when you leave the method. And in this get input method here, right? Token create, you know, the create command, first, it's going to create the new employee using the fields you provide for, I believe, first and last name, last and first name. And then it's going to call the expand method, and it's going to send along your object's EMP to that, right? So when it says, here's the method that adds a new employee to your array, yeah, expand does that. Now, we can take a look at the application assignment. I'll talk a little bit about, you know, in general details about what needs to change. Get away. Okay. So first of all, yeah, you're going to make a GUI class, right? You understand that. And instead of using the console, you have commands through the GUI by primarily text fields and buttons. Other than that, the e-tracker will be the same, right? It's still going to have an array of employees to manage, and it's basically going to do the same things, except, again, what do we have? So what will definitely have to change here, the get input method, it reads it directly from the console, but you won't be reading it from the console anymore, right? Instead, you will be reading it as inputs from the text fields. So instead of having the string tokenizer that breaks up the user string, you'll just, in the proper sequence, read the data that someone has put. So for example, in create, right, if you do create, you'll have to have something in place for the last name and the first name, right? But again, ignore the ID text box. That's going to be automatically assigned by the program. Okay, it'll be the next available index in the array. The other things that might be a little, right, tricky. So this, oh yeah, time permitting, I'm going to make a program and give you an idea of how the GUI should look. I mean, I'll get that done over the weekend. It's not super urgent. When does this due? Oh yeah, it's due in a week. All right. So the new commands, right, show, if somebody presses the show button, it's going to display whatever employee record is there in the ID value. So up the top, right, you'll have these three text boxes, first name, last name, and ID. So if you enter in an ID value, the show will display down below in the lower panel. It'll display the employee's first name and last name, right? That employee record. These two, the greater than, less than, or less than and greater than, they're going to scroll through the list of employees. So if you have one or more employees, right, going through this one, the right arrow will go to the next higher one, the left arrow will go to the next lower one, and, right, where do we go? Yes. Right. Oh, they don't have to wrap, or I don't think, I have to read this. It's a little at a weird angle for me. No ID value, show the lowest value, they'll show the highest value. Yeah. Next or previous, yeah. So it doesn't wrap around. There's nothing in there that says it has to wrap around. So for this, if you get to 0 and you're displaying 0, then doing that will do nothing, right? Likewise, if you're looking at the highest index in the array and you press the next button again, well, there is no next one, so it's going to do nothing. I should put out a clarification on that. Okay, and then update, right? That allows you to change things. So whatever the ID is in the text box on the top panel, you can update it to first name or last name to whatever you want. So those are the features you can implement. So I don't know, questions about those? But I'll put out the clarification. I need to do that, and I'll slap together the application so I can have a screen of how it might look.
I just had a quick question in regards to the E-frame, or like how we're building it.
Sure.
Should we make a class outside of eTracker building the E-frame and then make a method inside of eTracker?
Doesn't matter.
Using E-frame? Okay.
Doesn't. You could put it all. Generally, I say all the file, right? That's what I typically do. I may not have said this.
Yeah, I think at the bottom it says to keep it in the same file.
Yeah, single file. There you go. Yeah, so you can do the same thing, right? So you can do you'll need to copy over because I have eTracker and employee as separate classes, but you'll combine them all into one, right? But same as anything, right? So you have public class eTracker, and then whatever goes in there, and then in the same file you have class employee, and whatever goes in there, and then class eFrame, extends, JFrame, implements, action listener, and whatever code goes in there. And you can put it all in the same file that way.
Awesome, thank you.
Yep, no problem. Anything else? No questions? I hope everybody has some fun coding this. It'll be a wonderful experience. Remember,
I did have just
go
one
ahead.
quick question.
Sure.
So this is kind of specific. One question that I've been having is trying to map the J buttons in eFrame to the methods in eTracker. And I understand that you have to create like an eFrame object in eTracker, but the way that I was doing it, I actually created like an eTracker object in eFrame, and it still got the method, but I'm not sure if that's correct
I
at
did
all.
the same thing.
It is legit to do. You can do that. Like I did in one of the coding demo examples. Yeah.
Okay.
You can always share the reference. You don't want to create a new object. But for example, right, so I'm just gonna get rid of all, make a new thing. Right, so for example, suppose I have, you know, again, public class eTracker, and it has all of its stuff, and it includes an eFrame, right? eFrame, EF, whatever. Okay. In the constructor for eFrame, if I wanted to, because the thing doesn't say you can't, right? It doesn't say how to do it. You have latitude to do that as long as it works, right? So the class eFrame could itself have an object eTracker, ET, right? And then in the constructor, eTracker, you just send along the reference, right? So you could say this.et equals ET. And that way, you have a handy reference to anything that you want to do inside the parent object, right? Because you often find yourself in this kind of situation where you have two objects and it's not entirely clear what the hierarchy should be, right? Should you say that eTracker belongs to eFrame or eFrame belongs to eTracker? Yeah, in a big system, you'd want to be more clear about how you set up, because this is not the most elegant way to do things. It doesn't scale well. If you're working with some big system and all of these objects are interacting back and forth, yeah, this isn't really the way you want to do it. But at small scale, you can get away with a lot of this kind of stuff.
Okay, because I'm just trying to figure out what's the best way to implement the methods of eTracker in the GUI format and kind of like have the inputs of the buttons correspond to those methods initiating.
Yeah, well, what you can do, for example, you'll have your action performed method, right? So whatever, void action performed, action event. Okay, if the actions are happening, right, they're going to get registered here. So you could actually do eFrame implements action listener. Okay, and then the eFrame, oh, sorry, no, it's still going to be, sorry, I'm a little, this thing implements action listener, so it gets the action performed. But with the buttons, every button would have its own action listener. Anyway, so J button, whatever, JB, right? Somewhere in the constructor, you could do something like jb.add action listener ET, right? So you can say,
oh, okay,
the eTracker is going to be the object that responds when the button gets clicked.
Okay, perfect. Thank you.
Yeah, no problem. Like I said, it gets a little bit weird because, it's not always clear which thing is which other thing. Another way to do it, if the, program didn't say you had to do it as separate classes, you could have eFrame actually have this eTracker functionality embedded in it.
So like extends it?
No, not extends it, but basically all the methods that happen in eTracker happen in eFrame instead.
Oh, okay. I was also theorizing that, but I was just like, I was wondering if like
right,
we needed
it's
to
the
absolutely
way, right.
keep the eTracker class.
Right. So the reason I'm doing it like this is so, people can see step by step that you're building one thing on top of another, and I'm trying to keep these things separate. But the fact that you're keeping these things separate means you have a little bit of this circular stuff where, in effect, these are kind of two classes that are bundled together this way.
Mm-hmm. Okay, yeah. Perfect. Yeah, that solves some of my questions.
Oh, good.
So I zoned out for a second. Is that void
Me
action
too.
performed action event E how you reach the E array?
No. Action event E is just a parameter. You could call it AE, call it,
Okay.
whatever. You call it event. No, it's the default way I label events in my code.
Okay.
But yeah, I mean, eTracker has an employee array, so yeah, you wouldn't want to actually literally do E. Anyway, no, it's just action performed when somebody clicks on a button, right? Then if I've set that the eTracker object is what's going to respond, then the eTracker object has to have that action performed method present.
Yeah, because the biggest issue that I've had is being able to reach the array from eTracker in my eFrame.
Yeah. So this is how you do that, right? This is kind of why I brought it up in one of those demo files the other day.
Awesome. Thank you.
Yep, no problem. Anything else? All right, that's all I got. I'll wait for this to finish compiling in Zoom and then I'll post it. So good luck.